Hello, everybody. I hope you hear me. So I will present you our solution to active optical assembly of multi-component photomechanic structure. A small word about our company. We are based in the south of France. We are about 70 people. And we serve a different market: photonic, medical, defense, aerospace. We have, of course, quality certification, but we have a large team of engineering team. 35 people are here in our engineering team, so we are able to develop a lot of solution. We have four product family. We build machine and robotics. We build specific optomechanics and optics, so we deal with the beam. We manage a beam. We build micro positioning and control, and we build electrical embedded actuator for different market. In optomechanical family, so we have very specific product like deformable mirror, like benders, like high power laser facility mirror mount, fast steering mirror, etc., etc. In the photonics, so we are in the business of optical fiber winding machines. We can build a specific system to assemble fiber connectors. We have different. We have built recently a test bench for measuring reflectance and transmittance and spatial filters, etc. So photonics is the main concern of us. So today I want to express you, explain you our new machine called Photomatix. So Photomatix is able to assemble complex photonic structure with a lot of components, with a lot of algorithm. So this platform has made assembly by gluing. We have two sets of 6-axis robots. We have one palette on which we have all the components to be assembled on the interface for assembly. That means the substrate on which we assemble the component. We have two automatic tool changer, 8 gluing and picking tools, 3 measuring devices. And for other machines, so we had laser welding, we can add a dynamic storage, we can add a slit beam profiler, we can add a polarizer, we can add a dispenser for grease, for example. So our machine is able to make active positioning with 1 micrometer final accuracy and 10 micrometer passive positioning with the help of vision. We have we pick and place the components through die collects or through grippers. We have glue dispenser, grease dispenser, and we have different possibilities of measurement for the active algorithm. And of course, we drive your laser source driver. We drive your laser source, sorry. To manage the machine, so we have developed a complete supervisor software called Photonsmart. It's a classical one based on, so you create your bill of material of your photonic structure. On each product you have to assemble, so you have the possibility to make a lot of measurement, a lot of pick and place, a lot of gluing, a lot of measuring on the process, on the product. You can make calculation, and with that you can assemble your product. So it's very pick and place solution software. So our supervisor has 4 modules: recipe edition, parameters setting up, step-by-step operation, and of course production. We produce in semi-automatic mode. All we can automatize, we automatize it, but sometimes we need the help of the end user. The recipe module is based on components list, bill of material, pick and place, gluing and curing solution. You can create your own libraries. So with the time, your libraries will be full of components, full of elementary operation, of sequence of operation, and you will be able to assemble more and more complex solution. One key point of our software is using artificial intelligence algorithm, of course, for vision control. So we are able to control the components in the magazine, to control the components in the gripper, to control where we will assemble the component and where is assemble the component at the end. So we completely control our assembly process. And for that, we use a very complex sequence with conditional assembly. We can do a scan loop for measuring, and you can build a custom algorithm directly inside the supervisor. You can mix laser command, motion command, measurement, calculation, and you can choose which component you will assemble for one product. We have different value added in our machine. Of course, we have a specific algorithm to limit the shrinkage, post-weld, gluing, UV curing modulation. So it's different solution to limit it, the shrinkage of the glue after assembly. You can have the operator cooperation for laser collection, wire welding, or decision on a complex algorithm. We can bring a lot of flexibility in our machine. We can add new measurement drivers, new product assembly, change a component in a recipe, or you can help you with a Sherlock Vision script. We have very complex algorithm where we can assemble two components in one time. That means you have 2 times 6 DTL optimization, and we have very specific intelligent artificial algorithm developed by a specialist. We can make aberration correction. We have a complementary station where you can prepare a complex subassembly, for example, to manipulate a synoptic on a support and to glue it. Then you take the subassembly and you put it in your global structure. We completely control the gluing by the check of the real size of the glue drop, check the real position of the needle. And then we can bring full process automation. You can add with the machine an operator workstation to prepare all subassembly on the substrate. And then storage, dynamic storage, when you can put all your pallets ready to be assembled. And then the machine will automatically bring the pallets to be assembled inside the machine. And we use a concept of reversible conveyors to do that. So the example of assembly are very diverse. So we started our customer application with DPSS laser, diode laser, fiber laser diode assembly, fiber photoreceptor LiDAR, and fiber LiDAR. We can do other photonic assembly, fiber connector, light modulator, fiber to PIC coupling, edge coupling, any optical structure, very tiny optical structure. So we have very precise positioning on tiny structure, so we can place less than 0.5 millimeter optics in a subassembly.